This is SpaceTime Series 28, Episode 60, for broadcast on the 19th of May, 2025. Coming up on SpaceTime, Gilmour Space's Eris orbital rocket launch delayed, the discovery of possible tectonic activity on Venus, and a billion-year-old asteroid impact in Scotland sparks fresh questions about life on Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Gilmour Space has scrubbed the maiden launch of its Eris rocket by several weeks following a series of technical issues. The test flight, which was to take place last Thursday, was initially postponed for a day following the discovery on Wednesday of a ground systems glitch with an external power supply on the launch pad. The company's spokesperson, Communications Chief Michelle Gilmour, says the issue was detected during pre-flight systems checks. She says the cause was identified, but mission managers ran out of time to implement the fix and fuel the rocket in time to meet the Thursday morning launch window. That forced the scrub and a planned second launch attempt the following morning. But then on Thursday evening, an unexpected issue during final testing triggered the system that jettisons the launch vehicle's nosecone fairings, which then fell to the ground. Company CEO Adam Gilmour says no one was injured in the incident, and initial checks have found no damage to either the rocket or the launch pad. A replacement set of nosecone fairings are now being transported to the Bowen launch facility on the northern Queensland coast from the company's Gold Coast factory. Gilmour says a full investigation into the cause of the unexpected deployment is now underway, and that could take up to 2 weeks, meaning the next launch attempt is at least 3 weeks away. The 23-metre-tall three-stage Eris rocket is designed to launch small satellite payloads up to 200 kilograms into low Earth orbit. But the maiden flight's only payload will be a jar of the popular Australian toast spread Vegemite. The 30-ton Eris launch vehicle uses a unique hybrid propulsion system, comprising a solid inert fuel and a liquid oxidizer to provide oxygen for the burn. Gilmour says the company hopes to start commercial launches late next year or early in 2027. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, the discovery of possible tectonic activity on the planet Venus and the billion-year-old asteroid impact in Scotland that sparked new questions about life on Earth. All that and more still to come on SpaceTime. A new study claims that mysterious giant quasi-circular features on the surface of the planet Venus may be evidence of a new type of tectonic activity not found on Earth. The findings, reported in the journal Science Advances, are based on archival data from NASA's Magellan mission, which launched to map Venus back in 1989. The authors say this ongoing tectonic activity may still be deforming the planet's surface today. On Earth, the planet's surface is continually being renewed by the constant shifting and recycling of massive sections of crust known as tectonic plates. These float on top of a partly molten, convecting, viscous mantle. Venus doesn't have tectonic plates to allow heat from deep inside the planet to escape, but its surface is still being deformed by molten material from below. Seeking to better understand the underlying processes driving these deformations, scientists studied a type of feature seen on Venus and not seen on Earth known as coronae. Ranging in size from dozens to hundreds of kilometres across, a corona is most often thought to be the location where a plume of hot buoyant material from the planet's deep mantle is rising up and pushing against the lithosphere above. The lithosphere includes the planet's crust and the uppermost part of its mantle. These corona structures are usually oval, with a concentric fracture system surrounding them, and hundreds of coronae are known to exist on Venus. The new study details recently discovered signs of activity either at or beneath the surface, which is shaping many of Venus's coronae, features that may not only provide a unique window into Venus, but also the Earth's past. You see, Venus is often described as Earth's sister planet. They're both about the same age and size. They were both formed at the same time in the same part of the solar system and out of the same materials under similar conditions. But whereas Earth was able to evolve into an oasis where life could exist, Venus developed a runaway greenhouse effect. It has surface temperatures of over 460 degrees Celsius. That's hot enough to melt lead. Atmospheric pressures on Venus are 100 times higher than what they are on Earth. And the atmosphere is a thick, poisonous carbon dioxide mixture, pushed down under a thick planet-wide cloud cover that acts as a pressure cooker. And those clouds rain sulfuric acid onto the ground. Now, there is what looks like snow on Venusian mountaintops, but that snow isn't ice, it's metallic. Venus rotates slowly backwards compared to most other planets in the solar system, with the sun rising in the west and setting in the east. And at 245 Earth days, a Venusian day is 20 Earth days longer than a Venusian year. The study's authors found their evidence for Venus's weird tectonic activity within data gathered by NASA's Magellan mission, which orbited Venus during the 1990s and gathered the most detailed gravity and topography data on the planet available. The study's lead author, Gail Cassioli from the University of Maryland and NASA's Goddard Space Flight Center in Greenbelt, Maryland, says coronae are not found on Earth today. However, they may have existed on our planet when it was a lot younger, a time before plate tectonics became established here. She says by combining gravity and topography data, this research has provided a new insight into the possible subsurface processes which are currently shaping the surface of Venus. As members of NASA's upcoming Venus Veritas mission, Cassioli and colleagues are especially interested in the high-resolution gravity data the spacecraft will provide. Magellan used its radar system to see through Venus's thick cloud cover, mapping the topography of its mountains and plains. And of the multitude of fascinating geological features the spacecraft mapped, coronae were perhaps the most enigmatic. Back then, it wasn't clear how they formed. In the years since, however, scientists have found many coronae in locations where the planet's lithosphere is especially thin and heat flow is high. Over the years, people have proposed different hypotheses to try and explain how they formed. The authors of this study developed a sophisticated three-dimensional geodynamic model to demonstrate various formation scenarios for plume-induced coronae, and they then compared them with the combined gravity and topography data from Magellan. And the gravity data proved crucial in helping detect less dense, hot and buoyant plumes under the surface, information that couldn't be discerned from topography data alone. Of the 75 coronae studied, 52 appear to have buoyant mantle material beneath them that's likely driving tectonic processes. One key process is subduction. On Earth, it happens when the edge of one tectonic plate is driven beneath an adjacent plate. Friction between the plates can generate earthquakes, and as the old rocky material from one plate dives back down into the hot mantle, that rock melts and is then recycled back to the surface through volcanic vents. But on Venus, a different type of subduction is thought to occur around the perimeter of some coronae. In this scenario, as a buoyant plume of hot rock in the mantle pushes upwards into the lithosphere, surface material rises and spreads outwards, colliding with surrounding surface material and pushing that material back down into the mantle. Another tectonic process, known as lithospheric dripping, could also be present. This involves dense accumulations of comparatively cool material which sinks from the lithosphere down into the hotter mantle. The authors also identified several places where a third process could be taking place, where a plume of hot mantle rock beneath a thicker part of the lithosphere is potentially driving the volcanism above it. The research marks the most recent instance of scientists returning to Magellan data to find that Venus exhibits geological processes that are more Earth-like than originally thought. Recently, scientists were able to spot erupting volcanoes on Venus, including vast lava flows that vented from Mat Mons, Sif Mons, and Stia Reggio in radar images from the orbiter. While those images provided direct evidence of volcanic action on Venus, the authors of this new study will need sharper resolution in order to draw a more complete picture about the tectonic processes driving corona formation. And the Veritas gravity maps of Venus will boost that resolution by at least a factor of 2 to 4, depending on the location. That's a level of detail which could revolutionize science's understanding of Venus's geology and the implications it has for early Earth. This is SpaceTime. Still to come, the billion-year-old asteroid impact in Scotland, which has sparked new questions about life on Earth, and later in the science report. Discovery of unexplained communications equipment in Chinese-made power inverters used in solar panels and wind turbines. All that and more still to come on SpaceTime. Scientists dating a massive asteroid impact zone in northwestern Scotland have discovered that it actually struck the Earth some 200 million years later than what was originally thought. The discovery, reported in the journal Geology, not only rewrites Scotland's geological history, but also alters science's understanding of the evolution of life on Earth. Previously believed to have occurred 1.2 billion years ago, the impact created the Stack-Fata member, a layer of rock that holds vital clues about Earth's ancient past, including how meteor and asteroid impacts may have influenced the planet's environment and life. The study's lead author, Chris Kirkland from Curtin University, says the key lay in tiny zircon crystals which acted as geological clocks. Kirkland and colleagues were able to more accurately date the impact to 990 million years ago. He says these microscopic zircon crystals recorded the exact moment of impact, with some even transforming into an incredibly rare mineral called rhyolite, which only forms under extreme pressures. Kirkland says it provides undeniable proof that a meteor strike did cause the Stack-Fata deposit. See, when a meteor hits the surface, it potentially resets the atomic clocks inside the zircon crystals. And these broken timepieces are often unable to be dated. But Kirkland and colleagues developed a new model to reconstruct when the disturbance occurred, confirming the impact was 990 million years ago. And this revised impact date occurred at around the same time some of the earliest freshwater eukaryotes began to appear on land. Eukaryotes are the ancient ancestors of today's plants, animals and fungi. And so it's raising fascinating questions about whether large impacts may have influenced environmental conditions on Earth in ways that affected early ecosystems. See, understanding when meteor impacts occur helps scientists explore the potential influence on Earth's environment and the expansion of life beyond the oceans. Kirkland says while the impact crater itself is yet to be found, this study has collected further clues that could finally reveal its location.
We don't know where the crater itself is, but we've got these fantastic sequence of rocks that tells about the impact, but we don't know where the exact crater itself is. There's this classic sequence of geology in Scotland known as the Torridon, and it has this unit called the Stack-Fata, which is an impact deposit, and it contains shot minerals, so we definitely know it's formed by a big impact. Unfortunately, we don't know where the crater is yet, but the sequence of rocks is really interesting because it contains early eukaryotes. So those are early fossils of land life, some of the first evidence of life on the land out of the ocean.
These are cells that have got individual parts to them.
Yeah, that's absolutely right. So what they look like in the rock record are these kind of crusty surfaces within the rock. So they're quite distinctive and they've been recognized for a long time. And because the impact is in the sequence that contains these fossils, the impact has been used as a marker bed to define the age of these fossils. But by using some new techniques here at Curtin, we've redated the impact deposit and shifted its age by 200 million years. So it's a billion-year-old impact now. And that really helps us understand Scottish geology a lot better, but also understand the relationship potentially how this ancient ecosystem responded to a large impact event and then the development of these fossils.
Is this telling us that this impact may have allowed the acceleration of the spread of eukaryotes? Because these are the life forms that eventually led to animals and plants and fungi.
Yeah, that's exactly right. Yeah, we do find right underneath where the impact deposit is, there is some early kind of traces of eukaryotes, but after the impact deposit, we find more evidence of these eukaryotes. The reason this sequence of rocks is so interesting is it's some of the oldest unmetamorphosed, so uncooked rocks of this age that contain these fossils on the planet. And the other interesting thing about these rocks is they're an old sequence of rivers and lakes. So this impact came into this ecosystem, brought a lot of energy with it, fractured the rock, set up a whole load of chemical reactions, and then we've got this lovely record of it preserved in Scotland of all those processes happening.
Without an impact crater, how do you know that what you're seeing was caused by a meteor impact?
Yeah, that's a great question. So by looking carefully at the rocks and the minerals they contain, so the sequence of rocks within it contains some diagnostic minerals within the geologist's favorite mineral, zircon. So we love zircon because we can date it, and we'll get to how we do that in a minute. But the crystals themselves have been fractured and broken and crystallized this new mineral called rhyolite. And the only way you can really form rhyolite is under extreme pressure waves. So it's pretty diagnostic of having an extreme impact event, both raising the temperature and recrystallizing the existing material that's there, but also developing these shock features within the crystals. And it's those individual little shock features that we can date by using an ion beam, that's a beam of oxygen ions, and picking out these individual little features that are smaller than the width of a human hair. And those are the individual features we can date, which allows us to kind of refine the age and hone right in on this 1 billion year old impact.
Zircons have been wonderful for geologists and astronomers and planetary scientists because of how accurately they're able to date events. What is it about these zircon crystals that make them such good timekeepers?
Yeah, so it's a fantastic mineral. So zircon, when it grows, it likes to incorporate a little bit of uranium. And uranium over time changes to lead. So if we measure the ratio of uranium to lead, that means we've got this inbuilt stopwatch because we know the conversion rate. The other important point is when the crystal grows, it doesn't like to incorporate any lead to begin with. So that means any lead that's present today has come from the decay of uranium. So that gives us our stopwatch, our clock. So if our zircon gets modified, reset, regrown during the impact event, that then allows us to make this direct connection between a mineral timekeeper, a mineral stopwatch, and that actual process that caused the shock metamorphism, the shock deformation, and then we can link the two things.
And I take it zircon's not easy to destroy geologically, so it's got to be a really high-pressure, high-temperature event to do that.
Yeah, that's right. It's one of these wonderful minerals. We can go to the outback of Australia and look right back into the deep time history of our planet using the exact same crystals. These zircon crystals extend all the way back to tell us about the formative history of our planet, but they also, under extreme events, do change and do get modified. And those extreme events, such as impact, we can date as well. So we can date the formation of the grain, but we can also date extreme disturbance to the grain, and that's what makes it so useful.
The fact that you haven't found the impact crater yet, what's that telling you?
Yeah, I think it's telling us some things. I think it's probably telling us that if we want to find the crater, we might need to get our scuba gear on and go off into the North Atlantic and look underwater. It isn't in the exposed crust of Scotland as we know it today. It's probably somewhere offshore, and there's been various suggestions about somewhere in the water off to the west of the Torridon, which is this beautiful area. It's kind of a fantastic area to go hill walking in, so it's a real pleasure to go there and do field work.
How do you actually determine the zircon crystal's age? I'm not talking about the uranium to lead ratios. I'm talking about the equipment used to achieve that.
It starts off going in the field and finding rocks and their relationship through the stratigraphy and taking a sample of rock and bringing it back to the lab, and then that's when the hard work really begins. So you've got your piece of rock and you need to get your individual mineral grains out of it. So how do you do that? The traditional way was to basically put your rock in a big vise and crush it and split out the grains. That doesn't work too well for our impact deformed zircon because we want to be a little bit more delicate with it. So we've got this technique where we basically fire a lightning bolt at the rock and it kind of breaks it along grain boundaries. So you've got this rock and then you push a button and basically the lightning bolt hits the rock and it turns to sand essentially. And you take that sand and you put it into a heavy liquid. So in the heavy liquid, the dense minerals will sink and the lighter minerals will float, and that then gives us the ability to individually pick using a pair of tweezers the grains out. So you make sure you haven't drunk coffee for several weeks beforehand and you're sitting with a microscope and a pair of tweezers picking out these individual grains, probably up to about 200 microns in length. You put them into epoxy resin and then you polish the epoxy resin, and that gives us like a cross section through the grain and have these beautiful internal textures like tree rings, and those are the textures that we can look at to determine their growth process. And then we fire our ion beams and our laser beams at the polished surface of these individual little crystals. So that's the full technique.
It's a painstaking effort.
It is, but it's so powerful because, this same technique is the same technique we use to understand the age of ore deposits. It's the same technique that we use to understand the generation of large volumes of continental crust. It's the same technique we use to date archaeological artifacts. So it's got a whole range of different uses, and really by linking these individual textures within the grains to a geological process, we can link it into the bigger scientific picture of processes related to meteorite impacts and potentially even the evolution of life. So it's a very powerful tool.
Where does this research go now?
So I think a really interesting thing that we've seen recently, we've dated a number of different impact deposits. We've dated some of the oldest impact deposits in the Pilbara here in Western Australia, where we're stretching all the way back to about 3.5 billion years old. And now we're looking at a much younger impact in Scotland at 1 billion years. They seem to be related to big changes in Earth's evolution, not only the biosphere, but also the atmosphere and changing big climatic conditions as well. What would be interesting is to get much more accurate ages on craters from around Earth, maybe even on the moon, and see if there's a periodicity or a pattern to the frequency of when impacts occur. And I think that's important because it provides a means of linking geology to astrophysics. So we then would have a mechanism of, linking these two sciences that look at things on very different scales and kind of joining them together and getting a better holistic understanding of our planet, but also our planet's place within the Milky Way itself.
Have you found any bits of the meteorite?
No, we haven't. The closest we've basically got a shock deformed zircon grains that link us back to that high pressure shockwave and that extreme temperature. The reality with most impactors is they're completely vaporized, so the amount of material remaining from them is so small it makes it really challenging to find that. If you get lucky, you might find a chemical signature, but it's very challenging to do that.
You say you were able to work out where the eukaryotes were. Were you able to see individual mats of eukaryotes?
Mm-hmm. Yeah, and we haven't, but there has been other paleontologists who have actually, done a lot of detailed work and gone all the way down to the individual cell level. Just being in the field, you can actually see these mats. So as someone who likes doing field geology and looking at rocks, you can see the stuff in the field, but when you get back to the laboratory, that's when you can really start taking it apart. And that's the beautiful thing with geology and using geochemistry with that. You can link observations on a whole range of scales, right from, the chemical and isotopic side down to the elemental scale, all the way up through to the crustal scale, the size of an impact. But also then it's really nice to think about the big picture, like thinking about impact events and if they're periodic, and that takes us back to, the size of the Milky Way and the solar system. So, that's what I like.
That's Professor Chris Kirkland from Curtin University. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. American energy officials have discovered unexplained communications equipment inside Chinese-made solar panel and wind turbine power converters. The undocumented communications devices were also found in China's inverters used for batteries, for heat pumps, cellular radios, and even electric vehicle chargers. Now, while inverters are built with communications devices to allow remote access for updates and maintenance, power companies usually install firewalls to prevent direct communications back to China. China dominates the world renewables market, and the rogue communications devices, which are not listed in the product documents, could be used to bypass firewalls and change the settings of an inverter remotely. They could switch inverters off to destabilize power grids and even damage energy infrastructure, triggering widespread blackouts, an ability that would be very useful for Beijing in time of war. The Chinese company Huawei, which is one of the world's largest suppliers of inverters, has already been banned from supplying equipment to Australia's national broadband network, and the United States has restricted Huawei's access to US technology, including its 5G network, accusing the company of activities contrary to national security. Scientists have for the first time found the genes linked to obsessive-compulsive disorder, OCD. The findings, reported in the journal Nature Genetics, identified 30 regions on the human genome which are associated with this debilitating yet often misunderstood mental health condition. The research involved more than 50,000 people with OCD and 2 million people who didn't have the condition. The authors were able to pinpoint approximately 250 genes which all played a role linked to OCD. A new study has found that the origin of reptiles may be up to 40 million years earlier than previously thought. The findings, reported in the journal Nature, are based on fossilized tracks uncovered at an Australian fossil site. The footprints belong to an amniote with clawed feet, most probably a reptile, dating back around 350 million years ago. A scientist in Canada with an interest in the supernatural claims to have uncovered parts of the brain that act as some sort of psychic inhibitor, which he claims suppresses a person's natural psychic, telepathic and clairvoyant abilities. But Tim Mendham from Australian Skeptics says this amazing discovery, if true, has so far failed to find any support in the wider scientific community.
It's a story by researchers in near Toronto who are looking into a suggestion that something in the frontal lobe actually blocks intuitive thinking, and that if they zap it through something called repetitive transcranial magnetic stimulation, it will unblock the blocker. It will sort of stop the blocker doing its job, and therefore people will be able to suddenly have the psychic abilities that they've always had unleashed. And then they can start doing telekinetic things, which is moving stuff. And the stuff they're talking about moving is a random number generator on a computer, which is interesting. I don't know how you actually physically interact with that, but never mind. I can imagine doing a dial, a physical analog dial, but I don't know how you interfere with a digital thing with your psychic abilities. Problem is, with this story, if it was interesting, it'd be great. It'd be fantastic, a real breakthrough. So if it was true, it'd be a real breakthrough. The trouble is it true? The only place I've seen this reported is a paper in a publication that's one of those pay-to-publish sort of journals. You give us, I think, $3,500 US, and we'll publish a paper. We'll review it, of course, and review the check. But we'll review the paper, and you get it in the magazine. So that's the only place I've seen this thing. Now, this should be a breakthrough. This should be everywhere. And I've been asking, I'm in Australia, so asking people in the US and in Canada what this is about, and they're having trouble tying this one down and locating any more information about this. Now, I believe that the institution where the main researcher is located is called the Baycrest Health Sciences. It's part of a university, I think, which I believe is true. It exists. The main doctor is known for having leanings towards this sort of psychic abilities and stuff, so it's probably not new to him. You've got to prove, first of all, that such abilities exist. That's been a very difficult thing to do convincingly.
It's never been proven, even though the skeptics have huge rewards out for anyone who can.
Yeah, one stage the skeptics had about $2.5 million going to anyone who can prove a psychic ability, and no one has. The Australian skeptics have got $100,000. The Americans have got $500,000 US. So there's a lot of money out there that someone with true psychic ability could then go and claim, and then they get the imprimatur of the skeptics, but they haven't done it. The psychics are actually very shy in coming forward, funny enough. A lot of other people do, probably who definitely believe they can do what they say. A lot of psychics, people who come to me, seem to definitely believe they have this psychic ability. But anyone under test so far, under proper tests, scientifically controlled tests, no one's been able to win the money from us or from any other skeptical group. It hasn't happened. They haven't been able to prove beyond doubt that they can actually do this, even close to doubt. So, yeah, this person has learned to, or show that they can unlock this ability in people, and that people can then use their psychic ability to move a random number generator, therefore they prove it. So all you have to do is zap everybody with RTMS, I think it is, which is this particular treatment, and you'll all be psychic. If that was true, if this could be done, the world will be different. It'd be a funny place. If you could really, literally unleash the psychic ability of people, it'd be a very interesting world. If the only thing they can do is affect a digital random number generator, you wonder how useful it's going to be. And it's only a 0 and a 1 that they're looking at. And
so you got a 50% chance anyway.
Yeah, that's right. But if you get an 80% success rate, 90% rate where they all come out 0, they all come out 1, or they all come out as you want them to come out, and as you said before, I want this to be a 1, comes up a 1. You have to do a lot of tests for a 50% result by chance to try and make sure it's not chance.
Just because you may have gotten 5 ones in a row doesn't mean it's 100%. It still means a 50-50 chance, just that it's happened 5 times.
That's right. This is called the Monte Carlo effect.
Yes.
Where people believe that if you go to a roulette wheel and it comes up red 5 times in a row or 10 times in a row, it's going to be black the next time. Not necessarily, because each turn of the dial has the same odds. To get that many together, yes, it's unusual, but it's not an indication that things are going to change. So the Monte Carlo effect is a common issue with gamblers. You think, well, it must change. My luck must change. The turnouts can't be this way. Well, they can be, because if one roll of the dice 50-50 chance, the next roll of the dice is also a 50-50 chance. So each one is independent. They don't affect each other. And that's what the Monte Carlo effect is supposed to be. Previous events are influencing future events. Doesn't happen. Certainly not in gambling. Probably won't happen with a random number generator either.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.